Hey guys, welcome to the next video regarding aromaticity. So this time we're going to be covering something called frost circles. All right, so we're still going to be going off what we learned in the last video, right? So keep all that stuff in mind. The 4n+2 rule, aromatic, non-aromatic, anti-aromatic. All right, so let's get started. So what is a frost circle? Well, in the previous video we talked about what makes something aromatic, right? What makes something non-aromatic or anti-aromatic. And that was a lot of it revolved around this 4n+2 rule for the pi electrons, right? And so the reason we're going to look at frost circles is it tells us where this 4n+2 rule came from, and also because they could ask this on your test. All right, so I'll just show you guys what a frost circle is, and I'll start that by doing it on a 4-membered ring. All right, and so how do we draw this? So let's give an example of some compound first. So this guy right over here. All right, so he has how many electrons? How many pi electrons? A double bond here and a double bond there. So that's two double bonds. So 4 pi electrons, right? So 4n+2 equals 4. Subtract 2, you're going to get 2. Divide by 4, you're going to get 1/2, right? So that's not predicted to be aromatic, right? So it's going to be, we're predicting this to be anti-aromatic. So what we can do is we can also draw a frost circle for it. All right, so what does this look like? You're going to draw this. You're going to draw it so that we have a vertex, a corner of it pointed downwards, right? And you're going to have like this dashed line running through the middle. The dashed line is not necessary if they ever ask you to draw it on a test. A frost circle on a test, you do not have to draw the dashed line, right? And I'm going to put these little orbitals next to them. All right, next to on each corner essentially. All right, anything below the dashed line, that's why I drew the dashed line, so we can better see the divisions. So anything below it is going to be bonding orbitals. At the line is going to be non-bonding. And then above the line is going to be anti-bonding. And we're going to fill each orbital. All right, so we have 4 electrons that we need to use. So remember the way we fill orbitals. You start at the bottom, right? And if you have, let's say, multiple orbitals, so let's say your lowest orbital is like this. Now let's say we have 4 electrons, but we know each can only fill 2. You must fill one at a time first, right? So every orbital must have 1 electron before we start double filling, okay? So at the bottom, we only have 1 orbital, so we can already just fill this guy right off the bat with 2 electrons. All right. Now we go on to the non-bonding orbitals. Those are the next ones. And there's 2 here, and we have 2 electrons left. We already used 2. So I put 1, 2. Okay. You cannot do this. That's not allowed. Right? 1, 2. So you can see that these 2 electrons are not paired together. Right? We have 2 separate orbitals, each with 1 electron. Right? This is not that stable. Now, it's in the non-bonding, which doesn't contribute or destroy any sort of bonding like that, but it doesn't make it any more stable. So this is anti-aromatic, right? As we figure out with the 4n+2 rule. Now, this example didn't really help us figure out where the 4n+2 rule came from. So we're going to go on to a 5-member ring. So how do you draw the 5-member ring? The dashed line that I'm going to draw is going to be right here. All right. Now, below the dashed line is always your bonding orbitals, correct? Your bonding orbitals, if you drew the frost circle correctly, you will have an odd number below that dashed line. All right, this is why I drew, and you also should have them at the bottom. This is why I drew the ring upside down instead of drawing a 5-member ring like this. If you drew the 5-member ring like this, and we put, let's say, the dashed line right there, you have 2 corners, each would get their own orbital, and if that's the bonding orbitals, right, then we'd have 2 here. But that's not correct, we have 3. 1, 2, 3. All right? That's why you want to draw it upside down, and we can't just say, oh, but I could put the bonding orbitals up here. Well, no, because that shows that they're going to be higher than the anti-bonding orbitals, which are those, right? Remember, the lowest energy starts at the bottom and goes up this way, okay? So that's how you want to do these. So erase that. Now let's draw in our orbitals. We're going to have 1 there, 2, 3, 4. That was a little bit bad. It's fine. And 5. Right? You could draw them a little bit above the ring. It's not a big deal, as long as it's clear in the test. Right? So if you really want to do it, you could have gone like this. They'll know. Okay? So an example, like let's say, of a 5-member ring that we could draw would be something like this. All right, let's do the 4n plus 2 rule first. So how many electrons does this guy have? 1, 2, 3, 4, 5, 6 for the pi system. 4n plus 2 equals 6. Subtract 2, you're going to get 4n equals 4. N is going to equal 1 when you divide by 4. We got an integer, so that means we are aromatic. All right. So let's see. We have 6 electrons we need to fill up. All right. First one, 1, 2. Next, we're going to have, now we had total of 6, just used 2, so we have 4 left. 1, 2, 3, 4. That's it. We have used up all of our electrons. Now, one thing to pay attention, you only get a non-bonding orbitals when that dotted line is directly cutting through 2 orbitals. In this case, it's not. You see it's above. So in this case, there are no non-bonding orbitals. These are all bonding. And both of these are anti-bonding. So there are no non-bonding here. So these 3 are bonding. The 2 up top are anti-bonding. So in this case, all of our bonding orbitals are filled up. All right. And so this is where the 4n plus 2 rule comes from. When we have all of our bonding orbitals paired, right, all the electrons are paired in the bonding molecular orbitals, then we're going to have the 4n plus 2 rule. You see, we confirmed this with the 4n plus 2 rule. We can also do this for a bunch of other different kinds of rings. We did 4-membered, we just did a 5-membered. A 6-membered would look like this. And remember, like I said, that dotted line is not necessary. Probably want to draw them same size. In this case, again, no non-bonding orbitals, but again, odd number of bonding MOs, that's what you want. All right, and you always want to have like that, one of the corners at the bottom. All right, so that would be a 6-member ring, so we have 3 bonding MOs. We can do 7-member rings, a little bit trickier to draw. not that great at drawing 7-member rings, but maybe if I draw on those orbitals, it'll be easier to see. So you see that dashed line would end up going over here. All right. And so we'd have, in this case, those are the bonding MOs. All right. So this is a 7-member ring, and we're going to have, again, 3 bonding. All right. And then we can have 4 anti-bonding. But you see the main goal is that we have these right here, they're going to be odd. Right? You want to have that odd number. Now, the only rings you're going to have that will have non-bonding, where that dashed line runs straight through orbitals, are 4-membered rings and 8-membered rings. All right. I'll try to draw the 8-membered ring. Let's see. One, two, three, four, five, six, 7, 8. Okay, and the dashed line would run right through there. So you're going to have those right here are the non-bonding. These guys are going to be anti-bonding. And these guys are going to be bonding. All right, so 4 and 8-membered rings have non-bonding. None of the others do. You see we have 6 and 7. The 5s, they didn't have any of the, they didn't have non-bonding orbitals. Now, you don't have to really worry about drawing the ring because, what they'll do on the test is they'll give you something to help you draw, draw it in. Like they'll give you a circle, because they're called frost circles, because what you can do to help you draw them is draw a circle, and then within that circle you can draw the ring to help you better get the corners in. So something like this. We can have this circle, and I can draw a 4-member ring. Something like that, and you can go 1, 2, 3, 4, and then fill in your orbitals. Okay, and so that's why they're called frost circles. So they will give you something on the test to help you draw it. All right, so don't get too nervous about that. And so I hope this video helped you guys. In the next videos, we're going to be going on to the new kinds of reactions called electrophilic aromatic substitution, and they're going to be revolving around using benzene and adding substituents to benzene, and how different substituents on benzenes can change how the reactions work. All right, I'll see you guys in the next video.